Imagine you've just written your first embedded system program. You're excited to bring your microcontroller to life, maybe blink an LED, spin a motor, or read sensor data. But then, nothing happens. No blink, no response, and you're stuck staring at your screen wondering, what went wrong? In this video by Ted from Nexaspaces, we're diving deep into the most essential skill for any embedded systems developer, flashing your code to a microcontroller. We'll explore how the process works, show you how to do it step by step on popular boards like Arduino and ESP32, and, most importantly, help you troubleshoot common problems. Whether you're just starting out or looking to fix that annoying upload error, this video has you covered. So let's get started. Let's begin with the basics. What do we actually mean when we say we're flashing code to a microcontroller? Flashing refers to the process of uploading a compiled program, also called firmware, into the flash memory of a microcontroller. This allows the microcontroller to execute the instructions continuously, even after being reset or powered off. Flash memory is non-volatile, meaning your code stays there until you overwrite it. Think of flashing like installing an app on your phone, but for a tiny, purpose-built computer. You write the code on your PC, compile it, and transfer it to your board's memory via USB or another communication interface. Every microcontroller has a small bootloader, a special piece of code that allows it to receive firmware updates over standard interfaces. Without this, you'd need specialized equipment to program it. Understanding this is key, because if flashing fails, it often means there's a problem with either this bootloader or how your development environment is communicating with it. Before we get hands-on, let's make sure you have everything you need to flash your microcontroller successfully. Here are the 4 essential components. 1. The microcontroller board. This could be an Arduino Uno, ESP32, STM32, or any other development board. Make sure it's working and compatible with the code you're writing. 2. A USB cable. Sounds simple, right? But here's the catch. Not all USB cables are created equal. Many cheap cables are charge-only and don't support data transmission. If your board isn't detected, this might be the first thing to check. 3. A development environment. The most popular is the Arduino IDE, especially for Arduino and ESP-based boards. Others include Platform.io for VS Code, STM32Cube IDE, and PlabX for PIC microcontrollers. 4. Drivers and board definitions. These tell your PC how to talk to the board. For example, ESP32 often requires the CP210X or CH340 driver, depending on the model. Without these, your board might not even show up in the port list. Optional, but recommended, a breadboard setup, external power supply, and basic components like LEDs and resistors. They help you quickly test if your code actually works once flashed. Let's now jump into the process of flashing, step by step. Flashing your code is a systematic process. Once you understand the flow, it becomes second nature. Let's walk through the steps using the Arduino Uno and the ESP32 as examples. Step 1. Connect your board. Use your USB cable to connect the microcontroller to your computer. Make sure the cable supports data. Most boards have a small onboard LED that turns on when properly connected. Step 2. Open your IDE and select your board. In the Arduino IDE, go to Tools Board and select your microcontroller model. For ESP32, you may first need to install the board support package using the board's manager. Step 3. Choose the correct COM port. Go to Tools Port and select the correct COM port where your board is connected. If you're unsure which one, disconnect and reconnect your board and observe which port appears. Step 4. Write or open your code. Let's start with a classic, the blink sketch. This simple program toggles an LED on and off every second, and is perfect for testing whether flashing works. Step 5. Compile your code. Click the checkmark icon to compile. This converts your human-readable code into machine-level instructions in the form of a .hex or .bin file. Step 6. Upload the code. Click the right arrow icon to upload. The IDE will reset the board into bootloader mode and transmit the compiled code. If successful, you'll see a "Done uploading" message. On the ESP32, you may need to press and hold the boot button during upload. This puts the chip into flashing mode manually. And that's it. Your board should now be executing your program. If it's a blink sketch, the onboard LED should be blinking at a regular interval. It's a small thing, but it's your first working embedded system. Unfortunately, things don't always go according to plan. If you've ever seen error messages like "board not found," "upload failed," or "device not recognized," you're not alone. Let's go over the most common flashing issues and what they typically mean. 1. Board not found or COM port missing. This usually happens when your USB cable doesn't support data, or the required driver is not installed. Check your device manager to see if the board appears. If not, try another cable or reinstall the drivers. 2. Upload failed or timeout error. Your microcontroller didn't respond to the IDE. This might mean it's not in bootloader mode, or it's busy. On ESP32, try pressing the boot button during upload. 3. Permission denied, Linux or Mac. On Linux or Mac OS, your user might not have access to serial ports by default. Use a command like sudo usermod ag dialout $user, then reboot. 4. Programmer not responding. This can mean you selected the wrong board model in the IDE. Always double-check that the board and port settings match your actual device. 5. Board keeps rebooting. This may indicate a brownout reset, voltage drop, boot loop due to a code error, or a failing power source. Try using a stable external 5V source or simplifying your code. Don't worry, these errors can seem intimidating at first, but they're totally fixable once you understand what they mean. Now let's apply real-world debugging methods to fix these issues efficiently. Here's how you become a flashing ninja. Case 1, COM port not detected. You plug in the board and nothing. First, test with a different USB cable, ideally one you know works with data. Next, check Device Manager on Windows or ls/dev/tty* on Linux. Still nothing? Try reinstalling drivers or switching USB ports. Case 2, ESP32 fails to upload. This one's common. You hit upload and the IDE freezes at connecting. That's your sign to press and hold the boot button on the ESP32 board just as the upload starts. This forces the chip into flash mode. You'll see the upload start progressing immediately. Case 3, upload succeeds, but nothing works. The flashing succeeded, but your LED doesn't blink, or sensors don't respond. Check. Did you connect the peripherals correctly? Is your code logic sound? Use serial.print statements for real-time feedback. Case 4, permission error in Linux. Run this command. Then reboot your system. This adds your user to the group that has access to serial ports. Case 5, random board resets or boot loops. This often happens if your code accesses hardware improperly, or your board's power source can't handle peripherals. Try powering the board from a stable external 5V supply and debug the code using serial logs. To avoid errors in the future and make flashing seamless, keep these best practices in mind. Use quality cables, data capable, preferably short and shielded. Label your boards if you use multiple types. Keep code modular, start simple and add complexity in steps. Install proper board support packages in your IDE. Use external power if you're running sensors, motors, or displays. Debug with serial monitor, print useful messages at each stage of your code. Back up your code, use Git or folders to avoid losing working versions. These tips not only help you flash successfully but also make your entire embedded development journey smoother and more professional. Let's do a real troubleshooting walkthrough. We'll take an ESP32 board and deliberately cause a flashing issue by writing a heavy code that crashes on boot. We'll try uploading it. As expected, the upload fails and the board goes into a reset loop. Now, step by step. First, we press and hold boot during upload. Success. We open the serial monitor and notice the board is stuck in a boot loop. We fix the code, reduce Wi-Fi startup delay, and re-upload. What if your board has no USB port? Or what if its bootloader is corrupted? In such cases, external programmers come to the rescue. These are devices like the USB-ASP, FTDI Breakout, or ST-Link V2. They connect to your microcontroller using ISP or serial pins and allow you to upload code, burn bootloaders, recover bricked chips. You simply connect the programmer to your board, make sure the pin mappings are correct, and use the IDE's burn bootloader or upload using programmer option. These tools are lifesavers in more advanced development and repair scenarios. Flashing code is the heartbeat of embedded systems development. Once you master it, you open the door to a world of smart devices, IoT applications, and real-world automation. So next time your code won't upload, don't panic, troubleshoot it step by step, and soon it'll be second nature. If this video helped you, consider subscribing to Next TED by Nexaspaces, give it a like, and share it with your fellow tech enthusiasts. We've got more in-depth embedded tutorials coming your way every week. Until then, keep learning, keep experimenting, and keep flashing.